Before we jump into the episode, I want to thank our newest How I Doctor sponsor, Savaro. Savaro is a top telestroke and neurology company that was built to fix one of the most predictable failures in modern medicine, getting timely, consistent access to a neurologist when you actually need one. Their team of board-certified neurologists deliver rapid video response, clear decision-making support, and continuity from the first exam all the way through treatment planning and management. Hospitals working with Savaro see faster door-to-needle times, fewer transfers, and measurable improvements in patient outcomes. And because Savaro was built by physicians, the workflows actually match real-world medicine. If you need stronger, faster, and more predictable neurology coverage, visit Savaro.com to learn more. And now, let's get into today's episode.
We're going to have, a little AI assistant in our smart glasses or whatever, right? With us at all time. It will see what we see, hear what we hear, and advise us at all times and make us smarter. But we'll be their boss, right? I mean, we decide what to do. They solve the problem we give them. So they're not going to replace us. They're going to amplify us.
Welcome to How I Doctor, where we're bringing joy back to medicine. We keep on having very special episodes of this podcast, and I think that just means we're growing and reaching the right people. And yes, it's another special one today. You've got me live in person on video with two of the brightest minds in artificial intelligence who want to make their mark on healthcare. Today, I'm joined by Alex LeBrun and Yann LeCun. Alex is a serial entrepreneur and co-founder and CEO of Nabla, building AI scribe technology, and was just announced as CEO of Advanced Machine Intelligence Labs. This new company, founded by Yann, plans to build a successor to large language models, something called world models that we'll get into as the next phase of artificial intelligence. I've had the pleasure to get to know Alex over the past few years, and I think he's one of the few technologists who has learned how to work and deploy within healthcare. He uses his tech background to build with speed while still being able to decelerate rapidly to the pace of change we are comfortable with in healthcare. My second guest needs no introduction if you follow AI or technology, and is an absolute rock star in my book, Yann LeCun. Professor LeCun is the ACM Turing Award laureate, that's the Oscars of computer science, the Jacob T. Schwartz Professor of Computer Science at NYU, the former chief AI scientist at Meta, and now the executive chairman founding Advanced Machine Intelligence Labs. I've followed Yann's work for years, so it's so exciting to get to sit down with him today. And if you haven't checked it out, his homepage at yann.lecun.com will scratch an itch for an earlier version of the World Wide Web because it's straight out of 1999 GeoCities. Today, I'm hoping they can teach us about the concept of world models instead of large language models for artificial intelligence, and how we can apply the concept in healthcare where they hope to have a major impact. Alex, Yann, welcome to How I Doctor. What is a world model, and how is it maybe different from what people are now used to as AI, like a large language model?
So think about how you act in the world. When you're facing a new situation, you want to do a task that you're not completely familiar with. You use your mind to essentially imagine what the result or the consequences of your actions are going to be. You can figure out a sequence of actions to arrive at a particular goal. Yeah. Whether you're building something or just any task that you're accomplishing, really. That's the idea of world model. The world model is a model or a computer program or something like that, given some idea of the state of the world at time t and an action that you imagine taking, will predict the state of the world at time t plus 1, resulting from this action. So that's very different from what kind of the current crop of agentic systems, if you want, will do. The current way agentic systems are trained, they're like LLMs. They just, predict one token after the other, tokens being actions, right? They have to produce an action blindly, and then just kind of, you cross your finger that this action is correct. And so the only way to make those things work is to collect lots and lots and lots of data for a particular task, and then have them just imitate whatever, action sequences humans do in those situations. And that's brittle. It only works in certain cases. And it requires collecting a lot of data for, training
the entire internet and everything that's ever been published in the world. Yeah.
That's right.
Yeah. It's really amazing how far you can get with just like extremely complex math that is predicting the next word and the next token. But it certainly is not everything. You run into the limitations. And I think those of us who are like playing around with large language models and trying to understand how they might fit into healthcare, we see where they start to break down. And it does seem to be that planning phase like you're talking about.
Yeah, absolutely. I mean, it's really impressive how those things work, right?
Yeah, totally.
And it was, a little bit of a surprise when it first emerged, but they're very useful, and there's a lot of people working on them, and a lot of people who should be working on them. A lot of money being spent,
lots of money,
infrastructure, to run them. That's fine, but they have some limitations, and you have to really be conscious of them, and they're particularly acute in healthcare or any kind of situation where reliability is really paramount.
Yeah, Alex, you're a computer scientist as well. What do you think the implications are of world models? Why are you guys so convinced that this will be kind of the next big thing in artificial intelligence and automation technology?
I think, as Yann described, LLMs are designed to process tokenized data, so anything with token, so discrete data with low dimension. And we know this is not how the world is working. And, babies, you often use this example, Yann, but babies as young as 8-9 months old already have a very good model of the world. So if you launch a ball in the air, sorry, I'm stealing all your... but you launch a ball, and then the ball somehow gets stuck in the air. Before 5 or 6 months old, babies are not surprised.
It is amazing that like the human brain, just with observation over time, starts to build these neuron patterns and understand these things.
It builds a model of the world and then uses this model to make predictions and planning. And we know, and all that can be done by animals without any notion of language or so we know that LLMs are like a shortcut focused on language that is very useful in many use cases, but it's just one side of how our brain works. It's just one part, small part of the brain, and we feel that to unlock new, further use cases with AI, we need to be looking for something else, something different from LLMs.
Yann, you've said that language is kind of the easy thing. The physical world is much harder. I'll give you guys what I think is maybe a translation into healthcare. We have this thing called sick or not sick, right? And sick translates to, often critically ill, something is dangerously very wrong with this human in front of me. And the interesting thing is, we often describe that as coming from our gut. We say it's the gestalt. Gen Z might call it the vibes are off, right? But there is a sense that I can, through years of training, I can look at a human being from across the room that has entered my ER and say, whoa, there's something bad here. Something is very dangerously wrong. I need to take action immediately. Is that kind of what you guys are trying to get at, is understanding the physical world because language has limitations that we struggle to put into words?
Absolutely.
Yeah.
If it were the case that you could, learn how the world works purely from language, you could learn medicine by just reading books.
Yeah.
And you can't, right? I mean, you have to do residency.
No. Yeah.
You have to put your hand on the belly of a patient that,
1,000 times to find the few that are abnormal. Yes, absolutely.
And to figure out if they have appendicitis or something, and, they resist and all that stuff, right? So, there's a lot more to the world than a textual description of it. And nothing replaces kind of first-hand experience. So that, and there's this sort of a pair of numbers that I cite very often, which is when you collect like all the text that is available on the internet publicly, it's about 30 trillion words.
Give or take a trillion.
20,
yeah, sure.
20 trillion words, maybe, which translates into 30 trillion tokens, something of that order, right? The token is about 3 bytes. Because there's only a finite number of them. So that's about 10 to the 14 bytes, right? One with 14 zeros. It would take any of us like 500,000 years to read through this. Enormous amounts of data and knowledge, right? Factual knowledge. But that's about the amount of data that a 4-year-old has seen through vision in 4 years of life. 4 years of life, psychologists tell us, is about 16,000 hours of wake hours. And we have 2 optic nerves with 1 million fibers each, carrying about 1 byte per second each. So it's about 2 megabytes per second going to the visual cortex every second. Do the math, and it's about 10 to the 14 bytes in 4 years. So there's just way more information in the real world in sensor inputs than there is in text.
I mean, is that the idea of how these world models get trained, built, is it video? Is it all sorts of data that's not necessarily text-based?
Well, so you have two types of world models. If you are in a discrete world, like, I don't know, computer code or something like that, or some, kind of toy situation of some kind, you can have a description of the state of the world, a description of an action, and predict the next state of the world.
Okay.
Right? For the real world, though, it becomes really complicated because if you try to take a video, then turn it into discrete tokens, which is a very stupid thing to do, but you might try it, and then try to use prediction to predict what's going to happen in the video, it simply doesn't work very well. Because the real world is high-dimensional, continuous, noisy, messy, complicated.
Very messy, very complicated.
Right.
Yeah.
And so the generative approaches that work so well for language really don't work for video or for any kind of sensor input. It could be medical tests or whatever.
How long do you think you guys will take until you have something that's ready to show somebody like me?
Yeah, so it's important to note that it's still at a research phase.
Yeah.
In order to get off-the-shelf, like universal world models that will be trained as close as possible as a human, will take many years, 3, 4, 5, maybe more years. And this is the goal, to have such an off-the-shelf model. But on the way, building this model, we will start to work on specific use cases with partners, industrial partners, in order to apply the world model vision to more narrow problems and use cases. And we think we can get results on these specific use cases before, earlier than 4 years, so maybe a year or two.
Yeah, I've thought of the large language models as kind of, if you think of a restaurant, like kind of the front of the house, there may be the interaction with the patient. Maybe they're helping ask the patient questions. They're summarizing information. They're helping the doctor to think. And then there's a whole other part of medicine that happens when I go to a place in my brain where I'm thinking, okay, what could be going on with this person? And I'm running through it in my head. I literally I stare off into space and I think about the problem of my patient in front of me and my plan and everything like that. And that I don't know how much a large language model is the solution versus maybe it's a world model, maybe it's something else as well.
Well, you're running your patient model, right?
Absolutely.
I mean,
that's where I go. Yes.
And so, if you can have a system that has such a kind of mental model of a patient, you could imagine using the system to predict what is going to be the effect of a course of treatment, right? And then predict what the outcome of this is, particularly for things like, chronic diseases like diabetes or something like this, right? And perhaps through optimization, figure out an optimal sequence of interventions that will kind of,
that's interesting.
Make the patient go to a particular state.
Thank you so much for choosing to listen and subscribe to this show. I started Off Call because I was tired of flying blind as a physician, and it brings me so much joy to know just how many of you are out there who feel the exact same way. The feedback we've received, the community we're building together, it's nothing short of incredible. I want you to know that I'll do everything in my power to continue to bring you incredible conversations that put clinicians back at the center and help to change the culture of medicine. If I have one favor to ask today, it's simply this. Please, please, please sign up for offcall.com and subscribe to our podcast. Both are completely free. And roughly 38% of the people who listen to the show frequently don't subscribe. So if you're one of those people, subscribe and come join our community. I promise not to let you down. Every single subscriber allows us to make this show bigger and better and to build a stronger collective voice that'll help us make change in medicine. And to everyone who's already joined and subscribed, a huge thank you. I want to take a moment to thank our sponsor, Savaro. If you've ever waited and waited for a neurologist to call you back, you know the problem that Savaro was built to fix. Savaro is a physician-led telestroke and neurology company that delivers rapid virtual neurology coverage that's reliable. Their board-certified neurologists connect by video in under 45 seconds, and they stay with you through the entire decision-making journey. Hospitals working with Savaro report faster door-to-needle times, fewer unnecessary transfers, and measurable improvements in patient outcomes. If your hospital needs stronger, faster, more consistent neurology coverage, visit Savaro.com to learn more. Yeah, Epic has this Cosmos thing that they're trying, and I think they called it like a large medical model, a large patient model. And their idea, I think, was looking at episodes of care and, taking hundreds of millions of encounters and saying, okay, we can say that if you're diagnosed with diabetes today, there's maybe 7 possible futures for you, and one of them is that you have a stroke in 12 years or something like that. It sounds like the world models would really be trying to predict what would happen next to the patient, not they will likely develop hypertension 3 years later or something.
I think also, and Cosmos is very useful and powerful, but it's the input of Cosmos is text, mostly, if I'm not wrong. It's the notes. And so I'm sure
great point. Yeah.
You don't have 100% of the patient state does not
represented
even
in the
if
medical
the note
record.
was written by Nabla.
Sure. Yeah.
Even if it's a perfect note. Sorry, it was the advertising part. The note is a very, very limited projection of the state of the patient. And so, and you cannot go, if your input data is that, then there is no chance you can go back to the full, you can guess things if you don't have the right data input.
Yeah, the more I read about AI and think of its application to healthcare, the more I'm just impressed with my own brain. That my brain, like on your point of like, oh yeah, you're just going to your patient model, accessing that in your neurons. I was like, oh yeah, and I didn't even have to like do any official work. I just go to that place. It feels like you guys are trying to figure out how to do that inside a cluster of computers.
So let me give a funny analogy, particularly if there are neurologists listening to us.
I'm sure there are. Yeah.
Okay. So our world model is in our prefrontal cortex,
yes.
like the entire front part of our brain, right? What makes human human. Of course, a lot of animals have, most of them have world models too. They're just not as.
I'm imagining my cat with its tiny little world model of
I tell you, your cat has an extremely good model of its own physics and dynamics, right?
They're incredible. Yeah,
they're absolutely.
Well, they have 9 lives.
Yeah, right. And so that's your world model, right? Your prefrontal cortex.
Yeah.
You also have an LLM in your head. So do we. Okay. There's one little piece of the brain right here, right? About this big, called the Wernicke area. That's what allows you to understand language. There's another one here, which is also about that big, the Broca area.
Yeah, Broca's aphasia and Wernicke's aphasia.
Exactly,
sure.
right? That allows you to turn thoughts into language.
Yeah.
That's your LLM. Now, the problem with the LLM is that it has the part that generates the text. It doesn't have the part that thinks. That's what we're trying to build.
I like that idea that the planning is a particularly important piece because absolutely, when I'm thinking about, maybe I have 3 options I could use to treat this patient's XYZ, I am, especially as an ER doctor, I'm immediately going through each of those algorithms to the final point of like, am I going to admit them to the hospital or discharge them? And am I going to give them this medicine or that one? Or what's the best medicine?
That's the chain of thought trick, right? The way we do reasoning as humans, or at least one way we should do this, is that we search for, like we imagine, like, in the case of your patient, right? You're in the ER, you have to make a decision pretty quick. You're using your model of the patient, and you say like, oh, if I do this, then this will happen. Or if I do that, then that other thing will happen. And then, oh, but I can do that before this other thing, and blah blah blah. Right. So you do all those predictions in advance, and you search for an appropriate answer using your mental model.
Yeah.
You're not just writing down symbols, right? Or thinking out loud. Like a lot of those thoughts are internal and use your internal representation of the patient.
Right.
They're not expressible in language, as you said before.
Absolutely. Yeah, absolutely. Yeah. We have this concept where sometimes we'll say that the patient looks worse than their numbers. When you look at them, you know something's very wrong with them. And then there's also the opposite problem. We don't have good words for this, but everybody knows it when you see it. Like, there's also people whose numbers look terrible, and then the patient's sitting there just twiddling your thumbs, and you're like, how is this person's, biology still working? Because they don't look right. Something looks wrong with them. Alex, maybe I'll ask you a little bit about Nabla and your success and just the challenges of working in healthcare. When I've worked with people that come from the tech world, you guys have data everywhere. And you can pass it around so freely. Versus in healthcare, we have, of course, rules for really good privacy reasons. What have you found, join in the healthcare community party about getting tools in the hands of frontline healthcare workers? It's a different challenge than I would imagine, what it's like at Meta or any other company.
Yeah, and tech people and tech companies are famous to fail, for failing in healthcare.
Very famous, yeah,
because
absolutely.
we come with a strong assumption. In my case, 100% of my assumptions were completely false. And actually, the thing that saved us is we didn't know anything about healthcare when we started, but we knew we didn't know. And so we decided to start our own clinic at the beginning of Nabla, in order to be the first users of our AI. So to have our own physicians, our own patients, and we can observe every day. We spend 10 hours a day with every physician, and then this is how we started to understand. And this is how I discovered everything I thought was not true. So for instance, we were all thinking that we needed to build very sophisticated automatic diagnostics AI,
really?
and then after just 3 weeks of running the clinic, I see the physicians. The only thing they love to do is diagnostic.
Yeah,
and I would have come to them and say, "Hey, I built an AI that is better than you. It's the one thing you like to do in your job. Very easy to deploy." So it's just one example.
How dare you? Yeah.
Also, something else we learned early on is that when we train an AI model, it's easy to go to 70-80% of accuracy. Then it's hard to go. The more each additional percentage,
incremental step is
harder than but we like to just deploy. For us in machine learning, in science, 80% accuracy is great, But in healthcare, I learned quickly it doesn't work because physicians are are trained to ignore something if it's wrong 3 times.
Yeah.
If it's not relevant 3 times on the screen, something in their brain, in their world model, teaches them to ignore all the warning you have in EHRs, you don't even see it. Yeah, I know.
N'existe pas. I mean, really.
And so this is my another example where 80% is not enough, even for a test, even for a pilot, because if it's not relevant enough, it will be ignored, and you don't have a second chance.
Yeah.
You just lost the physicians, the user. So it's another example of the many things we learned during the 18 months when we ran our clinic.
I think it just speaks to the challenges of both electronic medical records and clinical decision support, and just sensitivity and specificity, right? I mean, I cannot tell you how many times an alarm goes off in the ER and the poor patient is staring up at the thing and freaking out that no one is coming to rescue them. And we don't even almost hear it because we know it's a false alarm. We would rather just turn off the thing entirely. That's just the challenge of building tools that actually function well. Because you're absolutely right. If you hear a false alarm enough times, you're not going to pay attention to it.
Yeah. So something else we learned is the product has to be very, very, very easy to use. Yep. It should be usable.
Usability is,
you have just a few minutes to demonstrate the value it will bring to the physicians. You don't have time or energy to invest more without having first indication of the reward you will get from the tool.
Maybe I'll ask you guys both. The OpenAI, Anthropic just both released their version of healthcare tools. Do you guys think that 1 to 5 years down the line, will LLMs have a big impact, or do you think we fundamentally will see LLMs for what they're worth, use them when they're valuable, and then when we think there's less value, we'll move to another type of model, like maybe like what you guys are building?
Well, I think there's a number of different uses of this type. One of them is just for people to get kind of a quick, informal advice, which they may or may not trust, which is a lot easier than getting in touch with your doctor.
Preach. I can't disagree with you, Yann. Yeah.
In fact, I have a friend, a former colleague, Mustafa Sissé. He used to be a colleague of ours at FAIR. He's from Senegal. He went back to Senegal and created a startup there, a company called Cara Health. And so he basically fine-tuned an LLM to provide medical advice in all of the local languages that people speak.
Wow.
And, relatively straightforward, super useful.
Yeah.
And in fact, he finds that even people who can see doctor talk to those LLMs. So I mean, certainly in developing countries, there's like a huge applications of that will help people a lot. But also in developed countries, just as a way of disseminating information and knowledge.
Yeah. Well, and I think the health literacy, I don't know about French people, but for Americans, I think has gone down. I don't think the number of times I'm showing somebody how to manage a nosebleed, or that it's okay to take Tylenol and Motrin together, or to use these medicines when you have the sore throat or the flu or something like that. What do you guys think it is that we are finally seeing a ton of attention and interest in trying to bring in more technology to the healthcare space?
So I think the recent tools we've built with AI for physicians finally addressed a real pain point of physicians, and not a fancy problem that engineers like, as I said before. And maybe it was the first time. So and by the way, the idea to I'm talking about AI documentation and ambient AI. Scribing, as you said, but I hate this word.
I know, you guys all hate scribe. Sorry.
The idea to do scribing has been around for almost 20 years.
Yeah. We had human scribes.
Yeah.
Right? We had, sometimes it was like a pre-med student, and we would pay them, and they would just walk around and write down what I asked and what the patient said. And now we've got an AI alternative. Yeah.
And finally, with large language model, the right technology was there, and we finally could deliver on this promise and solve this problem. And I think maybe for the first time, this technology addressed the physician's needs, the actual need, and not
I think you're right.
The administration needs or the CFO need.
That said, the biggest use of AI in medicine is imaging.
Yeah.
So, for, understanding, analyzing images, and for MRI to accelerate the process of collecting the data. So you don't have to, you can get a, full body MRI in 40 minutes now for $500, right? It's pretty amazing.
Yeah.
It's actually the result of a project that I first discussed with Dan Solikson at NYU in the radiology department at NYU.
Oh.
And we said, could we kind of maybe use AI to, improve the quality of MRI and maybe reduce the time it takes? And that just snowballed. Then a bunch of people in the radiology department at NYU and at FAIR, at Meta, the research lab, started working together. Meta had no interest in healthcare application whatsoever, but that project was really cool and ended up being published, open sourced, and everything. And now there's basically a version of it in every MRI machine on the market.
Let me maybe ask you guys in our last 10 minutes or so, kind of just about vision and the future. Alex, you said you're not going to get rid of my job. Thank you. The thing I always say is there's so much work to do in healthcare that I think we will all be happy to have some of our job replaced. Like if World Models, if your new company takes off and works in healthcare, who are the winners and who are the losers?
So I think the right picture is, and this is maybe a little difficult to kind of imagine for a physician. But the picture,
oh no,
the picture is like you are. Let's say you are a professor in a university,
okay,
and you have your entire lab. You have PhD students and postdocs, right? They're smarter than you. Usually,
yeah, that's
right.
That's what you want to do.
The whole point is what you want, right? Hire people who are smarter than
you. That's right.
And so, when you say something stupid, hopefully they'll tell you, and they'll correct you. So you have a staff of people who are smarter than you that work for you, right? And that's going to be our relationship with our AI assistants in the future. We're going to have, a little AI assistant in our smart glasses or whatever, right? With us at all time, it will see what we see, hear what we hear, and advise us at all times and make us smarter. But we'll be their boss, right? I mean, we decide what to do. They solve the problem we give them. So they're not going to replace us. They're going to amplify us.
That's amazing. I mean, I'm hopeful that and I think we're starting to see with AI documentation that physicians are able to go back to the bedside, spend more time as interpreters, translators, healers. I mean, be an amazing system if we could get back to that. What part of being a physician do you guys think maybe disappears first or starts to fade away first? We've talked about documentation a bit. Do you have a sense you guys might focus more on diagnostics, management, prognosis? Is there one that is easier for world models or more strategic?
One that would be, I think, easy, not easy, but shorter term.
Yeah, fair.
One that would be shorter term is medical coding, where this is something that looks simple as long as
it's text,
and when you try to do it, and then you realize, and even with LLMs today, coding you just work basically looking at in the past for similar cases, and then you apply the same code, but it's not the right way to do coding, and that you want some kind of reasoning using explicit guidelines. So it's a mix of reasoning over guidelines, but also experience in the past. And current technology is really bad at that. And I think this explains why nobody has managed to do 100% accurate coding, and nobody in the world like to do coding. I think it's if you
certainly
find
not
one
physicians.
physician,
yeah. And if anyone, I mean, I think that's probably the other way you guys, win hearts and minds. You say you could take away by coding and the 9-page, document I have to fill out. Yeah, I would love all that.
Yeah, and on top of that, if you are cautious and you don't code, you miss revenues, and if you are too aggressive and upcode, then you may have consequences. So on top of the burden to do coding, you actually have some risks.
I mean, that is the fundamental tension that I think physicians feel is, at least in the United States, many of us are employed by a large health system. That health system wants to get every dollar out of that code. And so, hey, this should have been a level 5 instead of a level 4. And so that's the piece that I think is really important, is just the tension and the friction that physicians feel at the end of the day, where we're ultimately responsible, but we've got so many different bosses who want us all to do things the way they want us to do things. And we've got our own opinions about how the world should work too.
I think ultimately it goes back to this question we were discussing initially of discrete versus continuous, right? So there's a lot of rules in medicine that are, I don't know how they were established, but like, to get back to the example of diabetes, right? They'll treat you so that your A1C is below 7.
Sure.
Right.
Yeah.
And if it's just a little bit above 7, like, increase the dosage of whatever, right? Because it needs to be like, there's no magic threshold at 7.
Correct. Yeah.
Other than, there are studies that show that, it's nice if it's below 7, but that depends on the person, that depends on dynamics, that depends on a lot of things, right? Decision-making doesn't need to be that crisp, in the sense that if you have an underlying model of the patient that really can predict the course of evolution of the, state of the patient or whatever, you don't need to have those crisp decisions. You can have a treatment that is optimized for the patient.
I mean, it's a great point, Yann. I think many of the quality metrics that we come across in medicine, like to your point, like the A1C needs to be less than this, the blood pressure needs to be less than this, So you can see these, I mean, literally there are multiple studies showing like step functions where it's like, oh, you turn 65, all these more people get colonoscopies, and it's like, well, they got Medicare. They have insurance now. So of course there's, and so yeah, I absolutely agree. That is fundamentally what doctors are trying to do, right? We are trying to say, you come in with septic shock, the guidelines might say, I need to give you 3 liters of IV fluid. And I might say, as your doctor who's trying to not think about the guidelines, just like be laser focused on what I think is best for you, maybe I think I only want to give him 2.5 liters or 4.5 liters, depending on your hemodynamics, your physiology. And if the model can help do that and like not get me in trouble with the bean counters, I think physicians would love that for sure. Yeah. I've got a couple lightning round questions for you guys in the last few minutes here. What specialty should be most nervous about world models?
Well, every single one of them, but not too worried.
Okay. Tell me why.
Well, not too worried because, again, you'll be their boss.
Yeah. Yeah. Love it.
But they'll help you.
Alex, what's the most overhyped part of AI in healthcare today?
Almost all AI.
Why do you think that is? Why is it overhyped? Because we haven't been able to deploy it, or it's theoretical, or
because some people are really good at marketing.
Yeah,
and there is a lot of money in healthcare, so all the ingredients are there to get overhype of almost every aspect of AI.
Last question, guys. Nabla built a clinic. How do you guys think you'll move Ami from research to healthcare? Will it be through learning through starting a clinic in that way?
So building a clinic was interesting for the reason I explained, but also a big mistake because it's very slow, very expensive. Now, if I could go back 7 years, I would partner with people like you, Graham, and we would have saved a lot of time and money in this process. So the idea would be, of course, to partner with providers, with clinicians.
There's a whole chain, right? I mean, there is the Ami's mission is really to kind of build generic world models that can understand any process and maybe help control anything that you want. And then working with partners for sort of particular areas themselves, working with partners to bring this to the practitioners in the case of healthcare, but other areas.
Well, guys, I cannot wait to see what you build. Please allow me to be an alpha beta tester whenever you're ready. I'm so excited. It's been a pleasure to get to talk with you today. Thank you.
Pleasure too.
Thanks, Graham.
Thanks for joining me today. For interviews with physicians creating meaningful change, check out offcall.com/podcast. You can find How I Doctor on Apple, Spotify, or wherever you listen to podcasts. We'll have new episodes weekly. This has been and continues to be Dr. Graham Walker. Stay well, stay inspired, and practice with purpose.